Okay. All right, so common student mistake is to model the situation with the e to the 0.03t. And we did demonstrate that it doesn't accurately model. You would get really, really close, but your answers would be very, very slightly off. Okay. Now, next it says verify that you get the same output for your modeling equations in both A and B when the output t is 4 years. If I put 4 years in this, so the first one is this right here. And then y of 4 is 100 times 1.03 to the 4th, and I get 112 550,881. If I take the other equation, which was y equals 100 e to the ln 1.03 times t, then y of 4 is 100 e to the, now I'm going to put a 4 in for this, but I'm going to write it like this, because power to power we just multiply. And so this would be 100, and these two things, whoops, it's an ln in front of that, these two things, e and ln, would cancel out, and I'd still get 1.03 to the 4th, which would still be exactly the same. Okay. Now, these are really important questions. Here now. Where does the yearly growth rate show up when you model with an exponential function of this form? So this one is this. And where does the yearly growth rate show up? And let me give you a moment to discuss that in your group. Okay, let me ask group 1. Where does the yearly growth rate show up there?
We haven't discussed it, but I would say it shows up on B.
In the B? So
Yes.
the yearly growth rate would be the B? You are on the right track. It's really close. the yearly growth rate, this is B is 1.03, but we would say the yearly growth rate in this one is not 103%, but 3% growth rate. 100% growth rate means you're doubling every year. 3% growth rate is each year you're increasing by 3%. So it's really close. What do you have to do to the B, to the 1.03, to get to the 0.03, which is this? You have to subtract 1. So it's the B, but minus 1. So for instance, if you had something like y equals 100 times 2 to the t, that's initial population of 100, and it's going to double every year. When t equals 0, you start with 100. T equals 1, it's 200. T equals 2, it's 400. But we call that not growing by 200% each year, but the growth rate is 100%. So growth rate is equal to b minus 1, which is equal to 2 minus 1, which is 1, which is 100% growth rate. Grows by 100% each year. Now, let's go to number 4. The population of 100 has an instantaneous, now notice this key new word here, not yearly growth rate, but instantaneous growth rate of 3%. This grows by slightly more than 3% per year in the same way that 3% interest compounded continuously is slightly larger growth than 3% interest compounded annually. Remember, if we did compound interest, hopefully you had this in pre-calculus class and you can remember a little bit of it. If you had 3% interest compounded just annually, your effective interest rate is 3%. If you have 3% interest compounded twice per year, so semi-annually, you would get effective interest rate of 3.01% interest. And if you compound it more and more often, it gets a little bit larger, but it stays really, really close to 3%. Okay, and and you can imagine two banks that live, that are right across the street from each other. That one says, "All right, we can't give a higher interest rate than the guy across the street, but we'll compound it more often. We'll compound it monthly." And the other one might respond, "Well, we'll compound it daily." And they could go back and forth, and the ultimate is compounded continuously. And the effective interest rate, instead of 3%, would still probably be like 3.04% or something like that. They hardly give away anything when they do more and more compounding. All right. So we're going to write the modeling equation for a population of 100 that has an instantaneous growth rate of 3%. All right. So if it's an instantaneous growth rate of 3%, it's going to look like this. Y equals population of 100, so it's initial population of 100. Now, instantaneous growth rate, we do E to the point, now it's not 1.03, but 0.03 T. This has an instantaneous growth rate of 3%. Now, this next part will kind of explain why it has an instantaneous growth rate of 3%. Find dy dt for this situation. Well, take the derivative of this with respect to t. The 100, derivative of e to the u, just like the practice quiz, is e to the u, times du dt, which multiplies by an extra 0.03. Now, here's the important part. This right here is y again. So this is equal to 0.03 y. When dy dt gives you the same, so y is a population. It gives you the same number that you have as your population, but just times 0.03. When this is true, now this is asking for the derivative. It's how much does y change every time t goes up by 1? But it asks it if you stay on the tangent line, provided you stay on the tangent line. Now, the tangent line, though, is not going to be the same, because this is exponential growth. The tangent line keeps changing all the time. What this is saying is the change in the population over the next year would be 3% of what its current population is, provided we stay on the tangent line. So if its initial population was 100, what do we expect the population to grow by over the first year? Would be 0.03 times the current population, which is 100. So we'd get, when t is equal to 1, when t is equal to 0, dy dt equals 0.03 times 100, whoops, which is equal to 3. So when t equals 0, we expect the population to grow by 3 units, provided we stay in the tangent line. But on exponential growth, we know we're not going to stay on the tangent line. So let me get some extra space in here. We know the curve would look a bit like this. It starts out at 100, and it's going up like this. And after a while, it's going to get steeper and steeper. So at the tangent line, is going to be an underestimate of the real value. So in actuality, that's why when we were doing these ones up here, we got a little bit too big of a number, because this is 3% instantaneous growth. And By the time you get for a full year, you'd have a little bit extra. Okay. Now, where does the instantaneous growth rate show up when we model with y equals a0 e to the kt? Instantaneous growth rate is k as a percentage. So 0.03t, we'd say the instantaneous growth rate is 3%. Now, number 5. When we deposit $400 at a fixed interest rate, 12 years later we had $520. Use y equals a0 b to the t to model the situation and state the yearly growth rate. Well, the initial deposit is going to be a0, 400, at a fixed interest rate, and b to the t and state the yearly growth rate. Now, the b is usually like if we knew that we were growing at 3% or 5% per year, we would use, like, suppose it was 5%, then I would use b to be 1.05. But I don't know what the interest rate is. 12 years later we have $520. Since interest rate is not given, b equals what is not clear. The only advantage to using the b situation was when you kind of knew the interest rate, and it would make a very quick situation. B is not clear, so we're going to skip. This problem doesn't seem to make much sense. Let's go to number 6. And this part, we've got overlapping. Let's bring this part down here. Alright, so put it down to here. Okay. Let me fix this thing on. This should come down to here. Right, so now use this to model the situation. A little bit more space, and state the instantaneous growth rate. So fixed interest rate. So we're going to say y equals 400 e to the kt. And then I'm going to go to the right here. I'm going to say an arrow. In 12 years, we're going to have $520. E to the k. I don't know what the k is, but I know that the time is 12 years. So this equation will allow us to find out what k is. So then we'll go from here, we'll divide both sides by 400. e to the 12k is equal to 520 divided by 400, which is 1.3. So then I take the ln of both sides. And what I'm going to get is these cancel out. 12k is ln of 1.3, or k equals ln of 1.3 divided by 12. So then my modeling equation is y equals 400 e to the k ln of 1.3 divided by 12 times t. And this is my growth rate. So let's punch this out on the calculator. ln of 1.3 divided by 12 is 0.0219. I round that off. So it's growth rate. And what kind of a growth rate was this? Instantaneous. Instantaneous growth rate. Is 2.19%. Okay, and we have run out of time, and we'll come back and finish this up at a later time. Your homework is 7.2. Again, it's not being spot checked on Wednesday because you have your first exam on Wednesday. On Wednesday, the first half hour, we'll cover some new material, and then we'll take the exam. All right. Quick feedback. How was the feed today? Was it any better than in the past, or did it break up more? Or as I talk to Comcast tomorrow, I need to let them know, did this modem reset help, or is it still the same? It broke up more for Yoon. Everything was good except the blackout. My wife and my son were saying, perhaps I'm having more problems because it was at, my other classes started noon at 12:30. Are any of you having difficulties with your connection middle of the day? If you have classes midday, do they have a hard, like everybody in Santa Fe is on the internet and it's overloading systems? Does that seem like a reasonable theory? And it's much worse at 1 for you. Okay, it's on Teams, but still, internet, I think they'll all work kind of the same if the internet connections are struggling.
So Bianca and I were just wondering if the recording saved for the first half before the blackout.